welcome to my next LeetCode video where I pick a random LeetCode and I show you my process from the first time seeing it all the way until trying to solve it, and then if I can or can't solve it either way, we'll have a look at the optimal solution after and just see where I went wrong, and then maybe I can learn and hopefully you can learn too from some of my mistakes or maybe even some of what I know. Now today we will be tackling our first hard LeetCode. First hard LeetCode ever. I'm going to be honest, I don't expect to get very far with this one, but you never know, hopefully we get an easier hard maybe. Maybe that might be better than one of those impossible ones. So anyway, enough talking, let's just pick a random hard one. Let's pick another random hard one. Oh, I've heard about this before. Let's start the timer and start reading. Alright, let's go. So, 51, N queens. The N queens puzzle is the problem of placing N queens on an N by N chessboard such that no two queens attack each other. Given an integer N, return all distinct solutions to the N queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the N queens placement, where Q and dot both indicate a queen and an empty space respectively. Oh dear, this is scary. So in this example, when n equals 4, so we've got a 4x4 chessboard, there are two distinct solutions, which are these two. This queen goes up and doesn't hit anyone going up, down, right, or diagonally, or left, but they're in the border. The top queen here doesn't hit anyone going either left, right, up, down, or diagonal any direction, and just the same with these two. And the same case is over here as well. I'm not sure if it's anything to note, but the two examples are mirrored, which we might take into account a bit later on. And to output that would just be, yes, the board configuration there, which makes good sense. And then when n equals 1, there's just one output. So let's go through an example and see if it will make sense. So maybe when n equals 3, then our chessboard looks like this, and we have to find, what do we have to find? We have to find how many ways we can place 3 queens. So if we placed one there, that would cover those, and it would cover that one and that one, and it would also cover that one and that space. So we'd only have these two spaces left. However, if you fill any of those spaces up, it will block the other one, so no queen can go there. Now if we place a queen there, let's see, is there always a solution? It does not seem to say. Well, let's just try and find one quickly. If there's a queen here, we can't put one there, can't put one there, can't put one there, but we can put one there and put one there. But if you put one there and then it blocks the other one, so we can't have a queen there. That's a bit concerning, because that means we can't have a queen anywhere on the border, because it's all just mirror images of the same case. So if we have a queen in the middle, unfortunately that blocks off everything. Now it doesn't tell me what to do when there's no solution. Maybe I'm going to guess that just means return an empty vector, an empty thing. But anyway, that was a good example to double check what happens when there's no solution. So let's just write down these rules, these requirements, just in these comments so we can refer to them more easily. So we want to find configurations of passive n queens on the n by n chessboard such that no two queens attack each other. Alright. Now, given an integer n, we want to return all distinct solutions. Each solution contains a distinct board. Yep. Each solution is the board configuration. And I have to work on keeping my comments a bit shorter just so they're quicker and easier to read. Now my first thoughts is that I recognize this question, but I've never solved it and I don't remember the solution. I'm not sure if I've ever actually seen the solution, but I know that I'm pretty sure it was used as maybe some sort of dynamic programming. Maybe backtracking. Which is interesting because the constraint is only that n must be 1 and 9, so it can be pretty, it doesn't have to be that efficient whatsoever. It can be pretty slow. It can be n factorial, and that will still probably be acceptable since n can be at most 9. Now, so something, or maybe not, maybe that would be a bit too slow, but something like checking every possible configuration might be a bit too slow, but it might be our first option maybe, and that hopefully will give us some good ideas on how we can optimize that. So if we think about a brute force, we could just do check every config of n queens. If they're valid, i.e. they don't, no two queens attack each other, we'll add it to result, just call it the vector for now, even though it's a 2D vector. Is it 3D? No, whatever. Let's try result vector. So let's just think about how we would do that. So first we'd have to construct or initialize an n by n chessboard just with 2 vectors. Got 2 vectors. That just with that. I'll just put that in brackets. And that would be, that's very inefficient. That would be n times the nested loop to check everything, I think. Very inefficient. Oh, I don't need to think about that yet. Put that at the end. And then nest a loop. Nest n loops, checking every possible configuration of the n queens. This is probably definitely going to be too slow actually, even though n's at most 9. I have a feeling LeetCode's not gonna love it, especially since it's a hard. If it's valid, add it to a result. Add the configuration to result vector. Why have I got that indented there? After that, just return result vector. Now the time complexity of this is, oh, is it? It's n to the n, is it? That is absolutely horrible, I think. If we're checking every possible configuration of n queens, that means n nested loops. Oh, that is pretty much n to the n, I'm fairly sure, which is bad. Space complexity there is a good question. I guess maybe it's because we have to build a chessboard which is big of n if n's the less an n by n, so it's n squared already, so it's at least n squared just for initializing a chessboard. And then we have to go through the loops and check every configuration, and if it's valid, add it to the result vector. So the result vector just is n times the number of solutions, but as the number of solution grows with n, it would be n squared plus n squared, maybe. So I think that just cancels down to n squared. So how can we improve this approach? Well, we can look at for each loop if 2 queens attack each other, there's no need to continue checking the rest, so we can exit. Exit. So if we say check when the queen's in the top left, and then our second loop checks when the second queen's there, we shouldn't make a third loop that checks when the third queen's there or there or anywhere, because those 2 queens stop the answer from being correct anyway. So there's no need to continue checking the rest. So break out of the iteration of the loop that causes a collision. Hopefully that makes sense. What else can we do? Good question. I'm not sure what else we can do. I'm just trying to rack my brain. I'm not seeing anything. Well, maybe we can start. This doesn't change the time complexity, unfortunately, I think. Could be wrong, but I think we should start. See if we can start coding some stuff up. So, So we need somewhere to check if a current configuration is valid. Either we can do that as a second function, or maybe that might be a bit inefficient. But we'll do the bulk of the main function first, just so we've got something. So we want to initialize the chessboard. Just call it, I think, vector thingy. Current config. Actually, we only need one of them, right? Oops. Now the question is, how do I initialize it to be the correct size? So we need a string of length n. Just call it row. I think maybe it's something like that. Whoops. Which will hopefully, I think that will initialize a row to be n characters long, and each character will be a dot. So now if we do the same sort of thing for our vector, and so we put row there and n there, that should give us an n by n row of dots. Now we want to nest n loops. How do we do that? Great question. Great question. How would we do that? Oh dear, how? So a normal loop just looks like that. Would it be? Yeah. But now we want to make a second one if n is larger than 1. So how do we do that? Maybe doing this recursively might be a bit easier, but if we can do it recursively, it's possible to do it iteratively like this. So how do we do that? Think. I don't know. just trying to think. We don't want to go silent, but I'm thinking we could do like some sort of while loop, maybe. Oh, maybe this. I think I might have just thought of another improvement we can do. Each nested loop, we start checking the positions of the next queen after position of the last one. So what that means is that if we're checking each thing of the queen, once we've placed one and we want to check a second one, there's no point starting from the start again, because we already would have found that while checking when we put the first one at the start. So what we do is we start from the second part. So I think that makes sense, but back to this problem that we're stuck on. What could one do? Interesting predicament. This is really annoying. Let's code out what it would look like when any was known. So we'll just have something like that, just so we can see what we need to repeat. That's when, whoops. That's when n equals 4, which is already pretty bad, but then we would also actually call this j and start from I plus 1. I'll have to change all of these, but that's okay. I'll just call that L, just so we're in alphabetical order. J plus 1, and that would be K plus 1. So now the question is, how would we do that depending on n at the start? Oh dear. I'm not quite sure. I'm absolutely drawing a blank. Alright, I'm drawing a blank, so maybe let's move on to what a recursive function might look like. So if we just call be a void, return nothing for now. It's just an experiment. And if we call it, just call it recursive, because we can change the name if we use this approach, but just for the sake of this, call it that. So it would take in n. Is that all it needs for now? Or would it also need to take in the previous index? And now it would do, like, well, the base case would be, no. I'll also do int none loops maybe, and do just int none loops equals 0. We would return whatever. We can change it if we need to, but now we stick another for loop in there. So for in I equals proof index plus 1. Is this n, excuse me, I plus. Do some fancy do we have to do anything? I'm not sure. But then we would have to do something and then call it again. Cursive and n would stay the same. Previous index would be I. Non-loops would be non-loops -1. Alright. And then if we actually, because I think maybe it's not most efficient, but for now we can make a second function. Just call it is valid, and we put in our chessboard. And that will just return true if valid, else, what's the word? Else return false if two queens attack each other. Alright. So now here this will actually be maybe what? Maybe we can also pass in our result. Oh, I forgot to initialize our result thingy. Result, yeah. It's just that result. Maybe we can pass that in by reference. And then, I'm trying to think. Well, straight away we can do result return. Oh no, return. We're not returning anything now, but we do is valid result. Oops. Then, no, not result. What do we need? We need our current configuration. Well, I'll just put that there for now, but we have to add it into the we have to add it into our parameters in a second, but just for now we would just do result push back config k, and then return after that. So in here, so do something, we'll do add current configuration. Also, before I forget, just put in result there. Fix that comment. Where was I? I just lost myself. Think. Add a queen, yep. But now for our little improvement down here. If two thingies thing, then if actually let me just put that thing. If it's not valid, after adding it, when we just do continue, maybe. Trying to think how our isValid function will work, but I think that hopefully should work that part. We just have to write some code to add a coin to the current configuration and also deal with the current configuration. So let's get rid of our nested end loops here, and I think maybe we would just, I don't know, we'll change the name after if we must. What we would do is we would do recursive and previous index 0 since it's the first time, num loops equals n as well, and result is just result. But now we also want to take in our current configuration, which hopefully that's all we would need to do. So we would also just add that on the end of there. So to add a queen, we would find, well, first off we have to find which string of the vector we're in. So how would we do that? I'm not actually sure if, no, I think definitely you can't just do like current config. No, because it will have to look something like that to change one of the characters. So if we draw that up, if we've got, is there a way we can draw a grid quickly enough? Well, we can do, that'll help us. And say that it's 3 by 3. Hopefully I can do this really quick. I thought I copy and pasted that. Never mind. That's a bit weird. Let's just do this real quick. Excuse my art skills. It's not very even, but you see what it's meant to look like. That's not bad at all. Alright. So empty spaces are dots now. So and say so n. Whoops. Oh yeah, n actually equals 3. So maybe we want to go. Hold on. We want to loop over every square for every queen. So maybe when it's I is less than I, because what this is doing is iterating over each square and adding one of n queens, which is num loops. Maybe we can just change that to a better name, like n queens left, just so it's easier to read. So we have to make current configuration correct. Whoops. So n equals 3 and say I equals 5. If I equals 5, whoops, we have to insert at this place, which would be 1, 1. Instantly, I'm not seeing a connection between 3, 5 and 2 1s. So maybe we'll pick a better example. What about over here? I equals 4 for what? The order we're going in. So what we could do, actually no, I doesn't equal 4, I equals 3. I apologize. Because that's 0, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, 7, and 8. So I equals 3, so we want to add it in at 1, 0. So maybe it's how many times I fits into 3 in the first one and the remainder in the second. So, alright, that's also meant to be like that. Nice and neat. Just kidding. So what we would do, so I hate modulus, I can't remember how to use modulus, but maybe it's something like n divided by I, and I'm not quite sure. That's a bit of a guess, but with integer arithmetic, n divided by I should give 1 if that's 3, 4, or 5. Hopefully. Or is it? That give 2? Because what would it return if it was n divided by 0 would mess us up if I was 0. Which is not good. Maybe we just have to double check a special case for that. But we'll do that. Well, no, we'll have that for now, and we will come back to that because I don't think it's correct. So adding the thingy to the thingy, adding the queen. I'll just call it queen. Hold on. Do I want to, after calling the recursive function again, change it back to a dot? I think I certainly do. And we will also change it back to a dot there before continuing. I think if current config, is already invalid, next queen. We don't need an else there because we continue. Then it comes to else. Continue adding rest of queens recursively. And then after we do that, we'd come back after we would return the current square to an empty space first. Empty space before we on. So now we need to do our isValid function. So a process for doing that could look like scan for queen, for every queen, check their each direction for a queen, turn false if any are found. Okay, so we just do for I 0, I is less. Actually, I think maybe, hold on. I'm just thought with this index thing, we'll come back to it, we'll do this one first, and maybe it'll help us. We actually just do row by row, which I'm thinking we can just implement that up here just to make that a little bit easier for what that means and that means. But we'll have to add another index. First j equals thingy, j is less than n again, j plus plus. So for each queen, if current field I dot thingy j equals a queen, we want to check. So now what we would do is do another loop inside. Oh dear. That's not good, that's a lot of loops. We can do another function, but I think this should hopefully be okay for now. It's been almost 45 minutes, but at least we're not stuck. You know, we're making progress. I might be going the completely wrong way and doing a completely inefficient solution, but we're making progress on a hard question, which is pretty good. So if current config thingy equals queen, we would go from each direction. So for int, we'll do u for up equals, what would it be? I. Because, oh dear, I'm trying to think. Because is I the row? Yes, it is. So I plus 1. I is greater, it'll be I minus 1. If we go up first, I is greater or equal to 0, 0, plus plus. If, oops, that's going to be that. That of it equals that. But that would do u. J, we would return false. Hold on. We can just go check up or down. We'll call it UD just for up down, and we will start at 0 and oops, I also did the wrong thing there. Press N. If that's that, and UD doesn't equal I, and return false. And then we go left to right. right equals 0, left parenthesis n, left plus, and now it's also going to be down, copy and paste that, so it's a bit easier. We'll call that, keep that the same. I think that should be fine, so I'll just add comments. Oops. Check up, down, check left, right. And then we want to check the diagonals. Oh dear. We could probably do this all in one loop, or in one, put everything in like one thing and check them all, but maybe that would be better. But either way, I think it should be alright. Check diag, top left to bottom right. We would do for, oh dear. Let's think. Maybe it will be easy to put it in the same thing here. Well, I don't know what to do. Let me think. So if we get our nice paint up again, and we've got a queen there, which is at 1, 0. We want to check 0, 1, and 2, 1. And we don't want to check these, but these are cool, and that's going to confuse us too much. Ooh, I don't know what to do. We can do, I mean, there's a way we can do it with a whole lot of loops and just do +1, +1, +1. I and j both +1, check it, check that one out over the edge as well, or both -1 and check over that, or +1 on one of them and check over that, +1 on the other one and check over there. I'm going to do that for now. We're in a hard question. We've got to kind of do anything we can to not mess us up too much. So what would we do? You don't quite know. My brain is already fried. I've spent too much effort already. I bet like the real solution would be like that long. It'd be like less than 30 lines, and I'd go, ooh, this nonsense. Man, I don't quite It's only been 15 minutes and I'm stuck on this tiny little thing. Just because it's a 2D array and that messes me up. Why am my brain's not moving? Maybe I need to go take a little tiny walk around the house and I'll come back. Be right back. I've sort of come up with a not very good idea, but hopefully it will work and just be messy code, but hopefully it should be alright for now. So if we just do while I is greater than 0 and j is greater. Oh no, we'll do new numbers. Int ni and j. J. And so while they're inbounds, we would like to, what would we like to do? And also go to the top left first. So what we would do is we would do where was I? Did just pop out for a bit, but hold on. So now this one's and that's that, and then do sort of the same thing. Hopefully this works. I'm not sure. Oops, that's meant to be J. And then we do so that will go to the top left. That will go to the bottom right. Our next one's going to go to top right. So I starts -1. Whoops. And that's right still. But now we have to do that. That should work. And now we want to bottom left. And now we swap these around. And if we somehow get to the very end of all that, we would return true. I'm definitely forgetting to do something. I know we have to double check. Change the indexes here, which shouldn't be too difficult. So if we actually previous I and do previous J. Hopefully we should be able to use that, right? Also, I think no, we'll do it 0 for 1 because I know we have to check the first one at some point. Which we just mess up here, so maybe we would do -1 at the start, but that should be all good. So if we just fix this loop up, I is less than n, yeah, I plus plus, and then do the same thing but with j. This might look a bit messy for a second, but it should be all good in a moment. So we're just updating all these ones. Yeah, so I reckon we can delete this part now. So now we do I, J there. So yeah, I think this might be best to be -1. And then I don't know what return result. I have no idea if this is going to work. Let's just go through it before we run it. I know I cheat too much by running things way too much, which is not an option in an interview. So let's just go through it. So we've done our 2 improvements that we thought about. So we initialize our chessboard and our result and our current configuration and our result vector. We just put that all as one. Whoops, can't do that in an interview. And then we call our recursive function, might as well give it a better name, which we can do, just call it add queen, just so it's makes a bit more sense. We don't look at this function because it's a bit ugly. But so we call it and we start as the previous. Yeah. Or is this continue? Yeah, that continues fine. Our previous indexes are -1 and -1, just so that when we start at I equals 0 and j equals 0. Okay, so what we do, and we also give it the result and our current figure, which is empty. Chessboard is the same thing. So we just call that initialize current configuration and result. And now we are keeping track of how many queens we've got left, which starts at n. And if it's 0, then we check if it's valid. Actually, I don't think we have to do that because we would have checked it there. Right? Oh, I'm not sure. Otherwise, it will just be a double checking just in case. So we'll leave it there just for now. Actually, now let me think. So each time we add a queen, we add it. We check if it's valid. If it's valid after adding it. Okay, so I think we don't need that. That's just redundant. We check it. We check if it's valid. We'll go through that code in a second. If it is not valid, we'll remove the queen that we put up there, and we'll continue to the next j or I, the next square. So else, if it is valid, we add another queen. Oh, I deleted the wrong part up here. Just that part we need. That part, of course. Anyway, so we add another queen. Because we don't want to just find the first solution. Which is why, is that going to work? I think it should. Because, yeah. I'm not sure. Oh, we add a return down here as well. And what this code does is it finds a queen, that's when we've got a queen, and then it checks the squares above it, and it checks the squares below it, and it checks the squares to the left and the right, and then it checks the diagonals, and if they ever find a queen, another queen, we return false, otherwise we return true. So let's run it and watch all the errors come in, as well as the time limit exceeded. Okay, so, it's a dot. Not supposed to be a dot there. Okay, so we've already got an error on the first line, and now on the second line. So maybe I've gotten mixed up. Maybe I've got them backwards. How's that? Otherwise I can look it up. Ooh, we've got something here. Why have I put K in there? It's meant to be J. Well, it's good that we've gotten to that point. N, where have I got N? Line 49. That's true. We can just, it's more efficient just to give it N. Let's just not a dot, we want a comma. Okay, it's taken too long. Now, why has it done that? I'm not quite sure. I'm stuck again. Okay, so what is the issue here? I feel like I've got a pretty good approach for what we're doing. I know there's more we can do, like not adding a queen in a spot where I is the same as the previous one, or J is the same as the previous one. But it can't be that much worse, can it? I mean, can it? I'm getting a bit stuck. So I want to just know if it's just too slow, if it's incorrect, or if we're getting stuck somewhere. Okay, now I'm just going to do what I normally do and Hail Mary some adding random things just to see if we get anywhere. Alright, I thought this return might make us quit out earlier. It's a very complicated algorithm to go through by hand. Not sure. Maybe we'll have our problems in here. So what if we return true every time. Ooh, is there a problem in here? Oh, I forgot to increment these ones. Definitely, that would be an issue. So while that turn false, else we would do I minus minus and j minus minus. I forgot to add this. I knew I had to do it, but I forgot. Hopefully this is it. I highly doubt it will be, but imagine if it was. G plus plus. Alright, let's see. Okay, it does not work. Worked for that one there, but did not work for this one. Well, the good thing about this is there's 9 test cases at most. So we can do 1, 2, 3, 4. I'm sure there's a limit to how many test cases we get before we have to start paying. What was 8? Not submit, no. Oh, I didn't mean to submit. Ooh, whoops. 3 out of 9 there, not bad. So which 3? Let me guess the first 3. Yeah, the first 3, and then it goes to poop. Because it doesn't do anything there. Okay, so what's the problem? We never seem to get to this point. Maybe we do, if it is valid, we do this part. Yeah, that makes sense. And next, when that makes a lot of sense. But has it done any difference? No. Quite fast though, which is good, but now we're going to get 3 out of 8 correct. But I'm feeling good about this. So what can we do? What? So I think hopefully our valid thing is working. I'm curious, what if we always return true? What do we get? Should give us some results. So it just gives us kind of all the results. I'm very scared that our error is in this thing because it's not very good. Can we give it any test cases? Sure, I think we can. So if we give it that, okay, we'll give it a test case, eh? So if we go stc out is valid. That which looks like that, I believe, n equals 4. That should hopefully give us a true. Hopefully. It does. That's a good sign. Now, if we just move one of them across, it should not give us a true. It doesn't. Okay, that's a good sign. So maybe our problem is in the main recursive function. Or maybe that's something else. And then do you continue it or what? Let's just experiment. Gives us nothing new. So what if we continue? Just experiment, we get nothing new. Because it looks wrong to me. But no, that should be right actually. Yeah, because we iterate over each square and we add a queen to a square, and if the whole thing is still valid, then if the whole thing is still valid, we add another queen. And now hold on. Because what if no? Because once we've gotten to the end and we've got this, we push it back, we return, we come all the way back and back and back and back here. Now I feel like that should be fine, should it not? Ooh, I'm missing something. And I don't know what I'm missing. Let me go through an example on a piece of paper, because paint will not work. Alright, straight away I have noticed that our previous index things will not quite work, because instead of going to the, instead of being at this square and then calling add queen on our new next thingy, instead of going there, we would end up going there, which is not what we want. So we want to only increase J if we can. Oh dear, what do we do here? Oh no, so we're at this space and we want to add a queen and search starting from this space. You know what, maybe it would actually just be better just to give the same I and I don't know, skip. Yeah. Yeah, I think that's a good idea. So if we just actually just pass on the index that the queen we just added, and we do if config I j doesn't equal a queen, then actually no, if we do that, we'll do continue. Otherwise, if we don't have that, every time we start adding a new queen, we'll try to add it in the same place, and we'll do that, and we'll check it's valid, and it's all valid, and then we'll end up with every queen at the first spot. So actually I should just keep that. Actually no, give this the same name as the previous one, and just do I equals previous, and now that should hopefully work. I would submit this in an interview as a last hope, but it does not work. Okay, why is that? What if we cat each thing? So we know where we're trying to add queens. And this should go on every square, I'm pretty sure. Oh, I'm not sure if that's going to be right, actually. Only one way to find out, though. We'll actually also do num n queens left equals n queens left. That should give us some more information. I'm hoping this gives us some good information. So we've got n queens left, there and there, and we've added one to there. Hopefully here we've got, so what's that look like? Hold on. So if we just do a square, and this one's 2 by 2. Is that in the middle? Sure. That's 2 by 2. So we've got 2 queens left. Hold on, there is it? Would it be -1? No, we've got 2 queens left, and we try adding one. Whoops, that's not the pen tool. We try adding one there. And I've got 1 tree left, queen left. We try adding it there. It does not work. So we've still got 1 tree left. So that one gets removed because of this map. And we try adding it there. It does not work. We do the same. Doesn't work. So now we go all the way back and we try adding a queen there. And now we try adding a second queen there. Doesn't. Oh no. Have I missed one? Or have I gotten confused? Try adding one there, and now we want to try adding one there now. So that's where we are there. And, ooh, why have we gone straight to there? Why have we done that? Why have we done that? It's a grand old question. Why have we done that? Why have we done such a thing? You know what, maybe it's easier actually to return the current configuration. Well, not return it, you know what I mean. Oops. Plus, maybe that'll be a lot more helpful. Okay, and then wait, so just so it's a bit more easy to see. So here we only check Q. That's 2, we check there, and then we check there, and we check there, and we check there, and we check there, and now, yes, why don't we check that one? That seems to be the errors of our ways. This one, yeah, this will go through freaking every single one until it's valid. Then it adds it, and it will be valid there, so we add a new one now. So I reckon that's it. And then when I actually get to a point where we have to change this one, we're in trouble. Or change any of them maybe. But that's, why am I looking at that? That's another very clear example. We'll check 3 if our thing is the same. See, why does our next one go down there? What is this continuing? Is it continuing the right thing? When that continues, what happens? But no, that's not even where that should occur, is it? It should occur after we've seen that something's not valid, and then we go to the next thing. It's weird. That's very weird. Oh, wait, is it? Hold on. Should we start I again? I'm not quite sure. I mean, start J again. Yeah, that's going to mess us up there. Yeah. Because what's happening is we want J to start again next time it enters a new row. So how can we do that? I don't know. But I'm convinced that is our problem. That's our issue. What could we do here? We want J. We want it to start there for the first time. Maybe, I don't know, we could do if I equals prev I to I equals prev J. That might work. So the will it work? I don't think so actually. My brain's fried. We'll test it. Too slow? What's going on? Time exceeded? What's happened? Why? So we put one there. It's valid. Now for 2 by 2 we put one there. It's valid. So we put one there. It's not valid. Put one there. It's not valid. Put one there. It's not valid. So we try starting from there. Oh, and that works. Try starting from there. Try starting from there. And now that is where we were messed up. Ooh. That's meant to be J. Come on, come on, come on. Come on, come on. Show me mercy. Come on. Nope. Let's see what's happened again there. I can't show. There's time limit succeeded from there. What? Oh, I guess that does make sense. I don't know, maybe we can do full first code equals true and just do if first code that. Maybe. I'm grasping at any straws I can possibly find. No, that's interesting. Interesting. Maybe it's... Oh, and I also forgot to change that, obviously. Silly me. Still not gonna work because I've lost all faith in my solution. No. But we've made some progress. So that all seems to work, that seems to work, that seems to work. That seems to work! So where do we get stuck? What's got way too many? We get past 3, we get past that one. Where do we get stuck? What case? So surely we've just like missed out our time limit by like a little bit if it's that many more characters, but that looks like it should work. Oh, and we should also do a little down. And so we can find it, we'll do something like that. Just for some more testing. Need the arrows, of course. Cannot forget the arrows. Okay, let me work. I'm rushing too much. I'm forgetting these little things. I'm pretty hungry. I've got pizza for dinner. Let's freaking go. Domino's pizza, leftovers, warmed up again. Delicious, delicious. Okay, so it does find one. That's fine. If it looks like that. Don't find one, we're not going to find one for 3. We should only find one for 4. We should find 2 for 4. Actually. Here we go. That's the first one. No way. And then this should be when the first coin's on the third one. And that's found. So we shouldn't find any more for 4. And we're going to have to go through a fair few though. What was that? Was that for 5 that I just saw? So annoying. Like this. Let's double check that should work. That. Yep. No, that shouldn't work. Or is it that one that works? It's the one. Is it the one before or the one? I should have done that, shouldn't I? Because that won't work. Would this one work? Looks like it. That's not going to hit that or hit those ones. That one's not going to hit any. That actually goes there. It just looks a bit off. That one's not going to hit any. That goes there. That goes there. That one goes there. Yeah, that should work. Where's the first found? Can I just Control F? Oh yeah, it does work. That's the first found. That's the second. Yeah, so it's the first one that's found, the one before and the one after it. Whoops. Nice. There's a lot for 5, is that right? I have no idea how to improve this. Is it really too... Oh, we'll submit it just so we've got it saved, even though it's too slow, but I want to save this to me profile and all that. So our time exceeds on the last test case. Ooh, that's annoying. What do we get up to? Well, a lot. That is really annoying. No, so that's not going to tell us anything. Well, I don't think I'm going to get any giant new approaches. I can't think of any other approaches except for something like some fancy... No, but I have no idea how you could... Actually, no, there's a few things you could do. Where's the console gone? Because why are we checking the same row? We know it's not going to be in the same row. Yeah, so maybe my next... Well, either way, we can do that at least, right? That would just improve our time a little bit, but like we're searching for tiny little things, tiny improvements. These, ooh, it is fast enough, but not the correct answer. Damn. Well, we get nothing. So we miss it when we do it like that. Because they're never going to be in the same row though. So maybe we don't need this first called thing anymore. I'll write in that. That should be fine. And that's going to be too slow. But surely a bit faster, right? Do we still get stuck on 8 there? No, we do even worse. So maybe not. I think we might. Oh, there's no hints. Come on, man. I guess that's a pretty famous problem. But we'll look at the discussion stuff in a second. I'm fuming. I'm really curious what I could have done. Let's see if we can make this any more fine, squeeze any more efficiency out of it. But like, we're not that close. Because what the max it's gonna check is a little bit more. It's not asymptotically any slower. Oh, man, I don't know, man. Let's look at some of what we've got. So it should never start checking a new one if the previous one is invalid, which is true. I really don't know how else we could do. We could improve this. What do these things mean? Format submission. Can I add any notes? I can. Is that the one I liked? Yeah. What notes could we do? Should find the correct answer. It's 7 out of 9 test cases. That is really annoying. I reckon, yeah, that's sort of the time that we've given up. Okay, so let's look at similar questions. Yeah, that's going to help. Backtracking. Yeah, backtracking. How could I have done that? Surely, is this backtracking? Because we check it, and if it doesn't work, we go back. Just a discussion saying. That's funny. Diagonal, silly. Yeah, I agree. It should have mentioned if we were to do this, but you know, it's fine. And yeah, if you don't know chess, it's pretty difficult. Ooh, that's 100 hard as a daily? Wow. What? Oh dear. Scary. That matters for C++ at least. Let's look at these, which hopefully there's... What the heck does bit mask mean? I don't want to look at that. Yeah. Ooh, what if we do something like... Yeah, checking if it had a queen before. That shouldn't do anything there, should it? No, I don't think so. I just want like a simple explanation. There we go. Cheeky, giving yourself a tick. So we're given n queens. Yeah, place them. Yeah. Can get very large. Over time, let's do n to the 2n. Is that not simplified to n to the n like I said? I'm not actually sure. No, it doesn't. So I just got I got it wrong. Each row. I tried doing that, and my submission doesn't do that. But I tried doing it. I couldn't work that one out. So I did that. So was I actually just a little bit off with the moving on to a new row? And probably this part is a bit too slow. I wonder if we could, if maybe we're stuck here. So maybe I rewrite my is valid thing because I haven't done it very well, have I? Yeah, instead of is valid, do is the queen safe. Then we only have to check that one. Obviously, I'm a bit silly. Current config. We'd also need our row and column, which would be I and J. So let's start this part again. and we'll just do what they did because I'm going to be here forever trying to do it again. And this is only a small thing. The main problem is this stuff up here. So, and yeah. So they did 0 and plus if current comes big oh, we need a different I. We'll call this K. And the column is J. That just means if there's a queen when we want to. No, it doesn't. What am I talking about? So that's checking the columns. And we don't need to check below it, do we? Because we won't ever get there. Whoa. Oops, not there. If row is I in our case, 1 is greater than 0. J is greater than 0. Well, and config. Which would be. Oh, it's not I, is it? It's not one, I mean. That's K. And it would be, that would be K. Current configuration. Row, which is I take K. And J take K. I've probably messed this up because I'm using silly variable names. And this is pretty much a very simple thing. And now that's J plus K is less than N. Oops. But I wonder if that's even just that's fast enough now. Whoops. No. Where'd my test cases go? I forget to change something that I changed. No, it's just because that's different. I got pretty close, but no sugar. No sugar. So if row equals the size of the board, surely that's better. So what have I got here? Let me just double check this is. Right, let's just change I and J to row and column. So all the I's. I's row. J is column. K is actually I now. There's a lot of them. Let's double check that's right. So Yes. N equals size of the board. So that's not actually right. N equals current size. Does that work? Oops. Whoops. Change the column. Yeah. Seems we're in a worse position. What's that? What did they do different? I think that's what they did. I think he's just gone fizzled a bit different. So what happens here is I don't know why you need to pass. You don't have to pass that as reference. Guess it's faster, but still. How have you got the solutions up here? No. How have you got? Because the solutions is up there. I feel like you can do that. Alright, so let's. I completely forgot that you can do that. So we only actually need the current configuration, my reference apparently, and our row. So look at our base case. We've reached the last row, so we have a solution. I don't know if that's explained very well, but we'll come back to that. Oops, fig.size. And then we do result push and return. Let's try fixing a queen on each column for the given row. Oh, that's true, because if you can't put a queen on one row, then you're stuffed. You can't do the rest. I see. I think I hope I see. So for int column starting on the left, This makes more sense. So say, right. And we can speed it up by just doing that earlier, but it doesn't matter. Go on plus plus. If it's safe to edit. That's different. For the blank space, if any coins are above, or diagonally above false. So go back here, is safe. Where are we? Here. Column. No, yeah, we do need column. Then we place it. Let's and then we go into the next row. Oh, I'm so annoyed. I was actually pretty close to solving it, but I was just doing a little bit too much work, it seems. And that should be it, I think. No, because we thought it is valid. That's fine. Not in capitals, it doesn't have to be super valid, just valid enough. Okay, no whammies, no whammies. We've done it. So if we submit that and compare it to what we had. I also like to ask ChatGPT just to get. So it's not super quick, which is fine. We can do a few things to make it a bit quicker. Like, let's see, we can give that n so we don't have to calculate it. So just do it for equals n. We have to calculate it again then, and the same thing there, and the same thing there, and then we have to do it again. And I feel like that should be a bit quicker. Is there anything else we can do quickly? Doesn't look like it. Instead of calculating the size every time, that should work. Oh man, come on. And that should be a lot quicker. Never mind. Not even a bit, it was slower. How does that work? Anyway, so running on to here now, this answer. Can we delete this? I don't want to see that one. Oops. I want to see this one. I'm not looking at anything, it's two. Yeah, it's two. I would like to ask ChatGPT what it thinks. Just out of pure what's the word? Curiosity. So I have a solution for the n queens coding problem. Please tell me how. I don't know. I'm usually better at writing prompts, but I just want to give it this and see what it thinks. It appears to work. Okay. Oh, I don't know that. Yeah, I should use inline maybe then. Do I? Oh, maybe that was messing me up. No, that shouldn't do anything there, should it? I want to do this one. How do I edit this? I don't bloody know. Copy and paste it. Yeah, that's not probably not going to work very well. So what if we run? Too slow, probably still, but hopefully something. Just curious. No. Still messes up. Okay. Please provide the improved solution then. If you think you're so good, Mr. ChatGPT. It's probably gonna, do that one pretty well. Oh, maybe. Let's see if this works. I'm just curious. Oh, we only need this stuff. Oh, I should have recorded what time I submitted the too slow. So it works. So what did I have that was too slow? That's annoying. Let me ask. Which parts would affect runtime the most? Or would be affecting runtime the most? Which part that I should fix? So I almost got the solution. So you know what? Actually, I'm going to go back to that one and just give it the improved is valid solution. Or function, not solution. You get what I mean. Now, if this works quicker, I'm not going to be happy. No, what do I have to add? What do they use? Yeah, I guess they kind of did a whole lot of different stuff. This is ing, right? I'll have to go back through my recording and see when I actually had a correct. Oh, so no, it's still too slow. Okay. Whatever. More things I'm forgetting or missing. So, excuse me. The add queen. curious where we might be messed up. You know what, maybe doing that actually makes it too slow. Having the prints. I would not be happy if that was the case. Just return them all, I'll run it again. Okay, so is that all of the printing? Yep. So what else is different? Not much. No way. No way. Well, the print's messing me up. Maybe it was that too, but if we go back, oh, I would be absolutely I will not be happy. Why am I doing that? The prints. No way with the print statements. Making it too slow. Surely this is valid things too slow as well. I deleted the wrong thing there. Actually, I hope that was it. Please don't tell me this was too slow. Come on. Oh, it's very I'm counting that as correct before, by the way. The other solution. Okay. Oh no! Oh no! 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 Oh no! Maybe I'm not. Oh, you're joking. Oh, you kidding? Are you for real right now, man? Let me see if it can do 9 by itself. So it must be. No. Oh, that is annoying. So it was this invalid thing. Is valid thing. Yeah, because we don't have to go to the bottom. Maybe I can delete some of this stuff. No longer counts. Just need to check up. Don't need to check down. So, that would be J. No. I. I is greater than 0. No, not I. UD. Should that work? I believe it to be so. And probably only have to check left as well, right? No. Let's get those test cases. Annoying. 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 Oh, wait, what? Why has that happened now? Have I screwed it up? Should do the test cases fine, shouldn't it? Or did I delete this top right part? Because we do need the top right part. We just don't need to go down at all. We don't need to go down or to the right at all. I mean to the direct right. So these diagonals are fine. Left and right. We need to go left. Only need to go left. So if we actually do it's less than J. Oh, that's what I should have done before, and if it's less than I, that should work as well, correct? I believe. Come on. Yeah, it's pretty slow though, so I'm going to test the 9. Come on, come on, come on, come on. Come on, come on. No. Oh well. I reckon I give up on trying to save my solution. So, yeah, this solution is pretty good. Are there any better ones? 4 milliseconds. Yeah, if I got that one working, it would have been like 3,000, so it's not very. Ooh, heavily commented. We like it. Ooh, I like this. This looks good. So, oh, why are you doing DFS? Oh, I think they're just calling it DFS. Oh, so it's pretty much the same. Let me get that other submission back. What's the difference? Oh yeah, I tried to make it faster and I made it slower. Apparently. So let's go through and add some better comments to this stuff, just so we know what we're doing. What does bit mask mean? Or is that another solution? Whoa. Oh, it's very fast. So the actual solution is you go row by row, which I got to, but I got stuck for whatever reason. Maybe for the end case I got stuck. Oh well, thank you for watching this video. It was almost a huge success. I almost solved it. You got to admit, I almost solved it. Just a bit too slow, but I reckon if the time constraint was a bit more loose, and by that, like 5 seconds. So maybe it was a bit worse than n factorial, to be fair. Probably most definitely. But that was a lot better than I expected for a hard LeetCode, my first ever hard LeetCode. But yeah, thanks for watching. Thanks for struggling through this with me. I'm sure you're yelling at me to do things because this is a pretty well-known question. But either way, thank you for watching. Leave a like if you enjoyed. Comment any feedback you have. Anything like that. You can stuff any criticism or things you liked all the good stuff. Yeah, I'll see you tomorrow in the next video. Thank you very much for watching this one.